Have you ever wondered what AI actually sees when it looks at an image? Well, I extracted these visuals from the brain of an AI model. Want to know how I did it? Let's dive in. This is the vision model VGG11. Don't worry, I'm not going to dive into all the complicated math and architecture. We can skip most of that. Here is the simple version. This model takes an image as input. Think of a nice 224 by 224 pixel photo with red, green and blue channels, and spits out a list of 1000 probabilities. Each number represents the likelihood that the image belongs to a specific category, like cat, dog or toaster. These probabilities always sum up to 1, so the model doesn't generate an image as output, it outputs a category prediction. VGG11 was trained on the ImageNet dataset, which contains over 1 million labeled images across 1000 categories. The model itself contains a ton of parameters or weights. You can think of these weights as tiny adjustable knobs. During training, these knobs are tuned so the model predicts the correct category for an image. For example, imagine training the model with this image of a cat. At first, the model's cat probability might be low, but as the training adjusts these knobs, the cat probability increases, while probabilities for other categories decrease. Of course, this adjustment happens not for just one image, but for millions of images in parallel. This is where things get really interesting. During training, the images stay fixed and the model adjusts its internal weights. What if we flip the process? What if we froze the trained model's parameters and instead modify the image itself? Let's start with a plain gray image. Next, pick a category, say cat, and ask the model, how should we change this image to look more like a cat? By tweaking the pixel values, we can make the model more and more confident that this is a cat. This technique is called activation maximization. Let's take a look at what kind of images we can extract for different classes. Here is the ostrich class. Now, here is the terrapin. And this one, it's a water snake. Here is the bullfrog. And finally, the balloon class. At first glance, these images seem hard to recognize, but we are definitely heading in the right direction. To improve these visuals, we can use a technique called total variation denoising. This method smooths the image by reducing sharp pixel differences between neighbors. Let's compare the refined version with the original. I think it's a huge improvement. Can you guess which classes these images belong to? This technique gives us a glimpse into the AI's mind, revealing the patterns and features it associates with specific categories. The results are often bizarre, abstract, and weird. It's important to remember that the model wasn't trained to generate images, it was designed to classify them. Yet, by working backward, we can uncover these fascinating visualizations. If you found this exploration interesting, don't forget to hit the like button and subscribe for more videos like this.